Good afternoon, VDMA members, industry colleagues, dear participants. Hearty welcome to all of you for today's interactive web seminar on the global production language, the next level of Indian production. It is our pleasure to welcome our esteemed guest speakers today. We have Mr. Ernst Stöckl-Pukall, Division Digitisation, Industry 4.0 from BMWi, which is the Federal Ministry for Economic Affairs and Energy, German government. And also we have Dr. Nagahanumaiah today, Director, Central Manufacturing Technology Institute. In fact, CMTI as one of the Industry 4.0 labs started, one of the 4 Industry 4.0 labs started by the Government of India, DHI. And also my colleague from VDMA Frankfurt office, Mr. Heiko Herden, who is consultant to OPC UAE. Also, hearty welcome to Mr. Julian Williams, who is Head India Industry Component of GPQI, GIZ, and our own Mr. Rajesh Nath, the Managing Director, VDMA India. This webinar is organized by VDMA partnering with GIZ and the Federal Ministry for Government Affairs and Energy, German government. We hope all of you and your families and working teams are all safe and doing well. I am Manohar, based out of VDMA Bangalore office, will be taking you through this initial phase of this program. A brief introduction about VDMA to all of you. VDMA, the largest industrial association in Europe, headquartered in Frankfurt. VDMA has more than 3,348 members and employs more than 1 million people, with the cumulative production from the members at 205 billion euros. Interestingly, 78% of this production from our members is exported out of Germany. 129-year-old institution, VDMA started in 1872. The entire activities of VDMA are categorized in the mechanical engineering sector into 38 specialized sectors. We have our offices apart from Belgium for the European Union in the SAARC countries. India was one of the earliest offices to start outside Europe, and then China, Brazil, Russia, and Japan. The program for today, we would start with a welcome address by our Mr. Rajesh Nath, Managing Director, VDMA, then a session introduction on Industry 4.0 by Mr. Ernst, and we would have the status Industry 4.0 in India by Dr. Nagahanumaiah, Director, CMTI, and my colleague would be Mr. Heiko Herden will be talking on zooming in Industry 4.0, introduction to the global production language. We would have a moderated Q&A session concluded by talk by Mr. Julian Willems, Head Indian Industry Component, 𝐕𝐃𝐌𝐀, and Mr. Rajesh Nath, VDMA India. Dear friends, I would like you to put all the questions in the question section of this platform. The questions would be collected and asked in the end of the web seminar today. So before we continue, I would like to introduce Mr. Rajesh Nath, his welcome address. Mr. Nath has been strongly promoting Indo-German relations and has been the face for VDMA for almost 20 years now. He has 3 decades of experience working in various industries in Germany and in India. He's been accorded the highest civilian order by the German government, Cross of Order of Merit, in the year 2019. And it's my pleasure to welcome Mr. Nath now. So over to you, Mr. Nath.
Thank you, Manohar, and good morning to all our members and participants from Germany, and a good afternoon to our members and participants from India. A hearty welcome to all of you at this web seminar being organized by the German Engineering Federation, VDMA, in association with the German Federal Ministry of Economic Affairs and Energy and GIZ as part of the global project on quality infrastructure on the relevant topic of global production language in the context of Industry 4.0. I extend a warm welcome to Mr. Ernst Stöckl-Pukall, Division Digitisation, Industry 4.0, Federal Ministry of Economic Affairs and Energy. Thank you, Mr. Stöckl-Pukall, for being with us today, and a pleasure to see you again, although virtually this time. I also extend a warm welcome to Dr. Nagahanumaiah, Director, Central Manufacturing Technology Institute, CMTI, my colleague, Mr. Heiko Herden, Consultant OPC UA at VDMA Frankfurt, and Mr. Julian Willems from GIZ, who heads the Indian country component of the Global Project Quality Infrastructure. Friends, in 1991, India showed foresight and courage in changing both the direction and the determinants of its economy. The results are for all to see. India's GDP of 266 billion, then in 1991, has grown by over 10 times. Our economy has become the 5th largest in the world. India transformed from an economy of scarcity in 1991 to an economy of sufficiency in 2021. Now India has to transform itself into an economy of sustainable abundance and equitable prosperity by 2051. This is the age of technical disruption and acceleration. The world will witness more changes in the next 30 years than it has seen in the previous 300 years. In fact, after losing out in the first 2 industrial revolutions and catching up on the third, India has now got an opportunity to lead the 4th industrial revolution. By deploying right technologies with agility, we can achieve quantum increase in productivity and efficiency. This will transform not only our industries and services, but also the MSME, agriculture, construction, and energy sectors. Technology-led development is the surest way to create a better India and a more equal India. As part of the transformation to Industry 4.0 and with the target image of plug and produce in mind, the German mechanical and plant engineering industry is making great efforts to develop a common language for industrial communication. While the OPC Foundation provides the grammar with the OPC UA communication architecture, the vocabulary is being standardized by the VDMA together with its members. This is how the global language of production is being created. In this web seminar today, we will highlight why the mechanical and plant engineering industry has selected OPC UA as the preferred standard for implementing Industry 4.0 communication in production. In the process, you will learn about OPC UA technology and gain insights into the various applications, options, and benefits. It is now my proud privilege to invite Mr. Ernst Stöckl-Pukall, Division Digitization, Industry 4.0 from the Federal Ministry of Economic Affairs and Energy for his welcome address. Over to you, Mr. Stöckl-Pukall.
Thank you very much, Rajesh, Nath. Great again to see you. We know each other since 16 years, or 15 years, we realized before, and it's great to see you again in this role. And thank you to all other participants and all people on the panel right now and contributing later to this event. Please allow me to say a few words more to the big picture today, and what the OPC UA, or this global language of production, really means for that. The project Industry 4.0 started 10 years ago in Germany. We celebrated on the Hanover Fair 10 years of Industry 4.0. What have we reached by now? I think we have developed a lot of concepts, and the German platform Industry 4.0 naturally played, or still plays, a strong role in that. But I think there is a next step coming right now, and you can see it everywhere. There is a vision now. There is a vision of Industry 4.0 or of the future ecosystems. We say that we have to shape digital ecosystems globally for the year 2030 and above. Because if you ask me, even in Germany, you have a lot of smart factories. They are really very greatly organized, they're very flexible. But when it comes to communication between factories, between the whole value chain, there is still a lot to do. And this is exactly what we mean by forming digital ecosystems globally. And there is a lot of ingredients already, but they have to be prepared to really be applied. And we talk that we come from more straight value change into flexible value networks. And to have those networks, you need definitely some ingredients. We have formed this vision for Industry 4.0 in Germany, and we see three main pillars for that. And I really like to put really a strong focus on that we have three main parts. First, you need always autonomy. You need self-determination and free scope for actions. You need to have free and sovereign use of your data. You need to be sovereign and strong to use your data together whenever you want or how you want. But you have to know what is happening to your data and this kind of things. What we mean by autonomy or sovereignty, by the way, and this is really to be highlighted. We don't mean to close any border, and to create silos. It's just the opposite. Sovereignty means, in that regard, that all players in an economy can openly develop business models in a fair competition. That's really an extremely important point. And for that, we need, for example, a digital infrastructure. I don't want to go in details right now, but you might have heard of the European project of Gaia-X, which exactly wants to develop such an open data infrastructure. And we know that it's critical for industry, because in industry, we have a lot of valuable, very sensitive data, and companies will only share it if they are sure that they can control what's going on with their data, and then that they can benefit from the outcome. And here's really a lot to do. And to understand this concept, I think that's one thing we should do in the role of VDMA, in the role of the governments, in the role of the economy as a whole, because to develop systems which are, how should I say, which are simply to use for SMEs is essential. That's one thing which drives OPC UA as well. A second pillar is sustainability. Sustainability means that we would develop systems for circular economy, but we also will develop decent work and education. We will help to prevent climate change or mitigate it if this is possible anymore. And the third pillar we are talking today is interoperability, and there comes really a tremendous change. With interoperability, we don't mean only simple to set a standard that we can simply put two things together. It's more, yeah. It means a regulatory framework which helps to form ecosystems. It has to, we need even to have global rules for that, yeah. Those national systems have to be compatible in some way to be able to exchange data, not only across companies, but also across countries. And we need definitely standards and integration. But what we are talking about, we're talking about decentralized systems and cooperation. We will see a different and a new era of cooperation, because digital business models can only develop if you have cooperation. So you see it comes together. Interoperability, autonomy, and sustainability is a big picture. And interoperability is the topic of today. And the German platform Industry 4.0 has somehow developed and pushed forward the concept of the so-called, and you all know that, yeah, asset administration shell. This is a model or a concept for having of an information model for the whole life cycle. So it does not mean only for the time when a product is being produced in a factory, but really the whole lifetime. And you need an information model, because if you want to have anything like a circular economy or sustainability, you need to be able to communicate across the whole value chains. And 𝐲𝐶UA is one important part of that, because this is a part of the global language of production. And without that, I think the other concepts would not be able to thrive. So I'm very happy today that we have an exchange between Germany and India about this 𝐲𝐶UA. By the way, this project is supported by the German Federal Ministry of Economic Affairs and Energy, so that you can do such kind of events, and that the German VDMA, who is very ambitious to form this language, and we are, as a government, we are sure that this language will help, and I mentioned it before, that we can make easier for SMEs to participate in the future value chain, because they need to have easy access, they need clear standards, they have to understand this concept, but it has to be applied in a simple way. And only if we do it in a way like VDMA wants to have it, yeah, and forms it together with a huge community, and not only a German community, it must be a global community. Only then SMEs, and I think SMEs are really most important for innovation, and strong networks have to be and should be part of it. And if we manage with this event today to bring more information about what are the plans of VDMA, what specifications for 𝐲𝐶UA are underway, how is it organized, what is the vision of the 𝐲𝐶UA project, then we have done a great job. And I'm quite happy that our colleagues who are, and I have to excuse Mrs. Roth, she fell ill today, and she wanted to say a few words about the global project of quality infrastructure, which is, as you said, Mr. Nath, it's a beginning, it's a joint event today, jointly organized. This is a very important project of the German Federal Ministry, because here is the importance how to secure quality in trade and machinery and so on. I think later on, Mr. Julian Wilms will say a little bit more about this project, but this is an essential part. And this global project for quality infrastructure is supported or facilitated by the German GIZ, and they have helped a lot to organize this, and this project is financed by the German government. So we see that we all have the same objective, and I'm very happy to look forward to a very fruitful discussion, information, and to the next step in bringing forward international or global standardization for Industry 4.0 and future ecosystem. Thank you very much. Maybe I was a little bit too long, but I hope I could at least draw a small picture about the vision. Thank you very much.
Yeah, thank you. Thank you so much, Mr. Stöckl-Pukall. I think that was really set the tone for the further presentations. You spoke about the three main pillars, which was very important. And you also, I think, very well highlighted how OPC UA as a global language of production. And I think what is important in Indian context also, Mr. Stöckl-Pukall, is how OPC UA can really help and benefit our small, medium enterprises, because in India, the MSME forms the backbone of the Indian industry. And we are very happy to know that with the support of the Federal Ministry of Economic Affairs and Energy, GIZ and VDMA would be doing more such web seminars in the days to come. So thank you very much for this address, Mr. Stöckl-Pukall. And again, it was a pleasure having you with us today for this first event, first combined event. Friends, friends, before we go to Dr. Nagahanumaiah, we would have a poll question. So can we have the first poll, Manohar? Yeah. So friends, I hope you can see the poll question. So the first question is, do you know or do you understand what Industry 4.0 and OPC UA are all about? And the options here is, yes, I know both. I only know about Industry 4.0. I know only about OPC UA. And no, I don't know both. So I would request all the participants, please give your choice. So I think it will also help our colleagues and the presentation following to know what is the level of awareness among the audience present. So we'll give a few seconds to complete the poll. Okay, Manoj, can we conclude the poll? So it's, I think, quite encouraging. 35% of the respondents know about OPC UA and Industry 4.0, and a good percentage, 39% of the respondents know about Industry 4.0. Yes, the awareness for OPC UA, I think, needs to be created, and that is what is the aim also of this web seminar, to inform the Indian industry, to inform the participants about the OPC UA. And we have 14% who don't know about OPC UA and Industry 4.0. So for these sector of participants, I think it will be a good learning for you as well as a good awareness on Industry 4.0 and OPC UA. So with that, now I would like to, it's a privilege for me to invite Dr. Nagahanumaiah, Director, Central Manufacturing Technology Institute, for his presentation on the status of Industry 4.0 in India. So thank you, Dr. Nagahanumaiah, for being with us today, and we look forward to your presentation.
Yeah, thank you very much. Is it audible?
Yes, yes, Dr.
Yeah, thank you all the delegates from German and Indian. Good afternoon, all of you, and my sincere thanks for an opportunity provided by VDMA. Basically, next 15 minutes, what I've tried to do is that the people who are not aware of Industry 4, I think, what is an Industry 4, what are the essential components, and then kind of setting a context why the common language is required. So apart from covering what is the kind of general awareness in India, what I think one line is basically the smart manufacturing or Industry 4. It is for optimizing the factory productivity by addressing the several challenges, but I call it as a 4P challenges, that is challenges related to product, process designs, people and production. mostly in the Indian context. I'm sure this is very familiar schematic representation of innovations, like technology push innovation, market pull, business design thinking, and platform strategy. My understanding is Industry 4.
Dr. Nagahanumaiah, you got muted. Can you unmute yourself, please? Yeah.
Hello?
Yes, now it's fine. Please go ahead.
Yes. Right. So idea is to basically the Indian manufacturing context. This is more of market pull innovation, partly business model innovation. The next slide, please. You are well aware of this is the vision of our Honorable Prime Minister, Atmanirbhar Bharat. I think since there are many of us, our German friends are there, so I just, for their sake, I covered this slide. What is Atmanirbhar is not, it is not a protectionism, it is not inward looking, it is not just import substitution, it is not even economical nationalism. So this is the process of creating an ecosystem that will allow Indian companies to be globally competitive and thus making India self-reliant. So how it is possible? Technology self-reliance will not happen overnight. There are different ways, but these three are the major events. How can we get self-reliance? By transacting, by taking, and by making. Next. So let us look at how this could relevant. If we really wanted, one would catch up this. If I look at transacting, taking, and making are options available for the Indian company. So now, can I transact or do business? Here, the Indian company manufacturing has strong pyramid. Is basically bottom of the pyramid is MSME. Each MSME has skill dependent and they are unique. Unfortunately, there are many skill sets are even not traditionally developed, but not documented. And second is the Jugaad innovations is still the USP of many MSME industries, means barring the high-tech companies. Mostly MSMEs, even today, their survival is because of Jugaad innovations. But the disadvantage with this is the assurance, the poor repeatability. So then can I purchase? Yes, again, it is difficult adopting the skills and capabilities developed elsewhere. Absorption is always a challenge in MSME because retaining intellectual manpower is really tough. But yes, in 90s, if you look at Maruti is one of the best known example because we acquired the technology, scientific manufacturing techniques from Suzuki. So that made India as a leaders in automotive companies, automotive manufacturing. But the same analogy may not work according to me in the current given time because this is growth rate is quite high. So because of ungated globalization, so it is, if you are not, so somebody else will be there. Demands are slows down due to several options. So now if I decide, okay, I will make it and develop it everything here, either by reverse engineering, re-engineering, original design, or innovative solutions. So these also have a limitations like technological gaps, because as I said, even Industry 4 itself is about 10 years back, it started in Germany. Then patent operability, originality, novelty, the capacity building and capability building. And second is whether for me or for us, that is itself is a difficult task in many of the cases, high-end technologies. Then investment and sustainability are the essential components of technology acquisitions. Survival is the only is by innovation. I think one has to be different from others. This is fully depends on how effectively we operate in collaboration and cooperation, both within the country, within the company, and outside the company or outside the country. Next slide. Next slide, please. So if I look at this is just to kind of elaborate what I told in the first slide. Product, process, people, and production. See, these are the stages: research. This is having a link to your TRLs, research, technology, training, then applications. So product designs, because one has to address the designs, maybe original design, re-engineered design, or innovative design. The process designs is a process specific or product specific or market driven. Then the people development is engineering fundamentals, is always matters. Then practice based learning, skilling, reskilling. Then production trends like machines, concepts, automations, supply chain, so etc., which are primarily the drivers in increasing or enhancing the productivity. That at the same time, all technology, whether we like it or not, it is invariably follows S-curve. So still Industry 4, both in India and across the globe, are still not reached to the inflection point. So it is under still introduction and the development stage. So this is the time for all of us, no matter whether it is Germany or in India, one has to engage, collaborate and cooperate and then innovate. And particularly this Industry 4 technology, I think if we focus on the technology development, not for me, for us, that is where the importance of this, the uniform production language, what we are talking UPI, this OPCUA is falls under that. It's not for one, it is for all of us. Next slide. Next slide, please. Yeah. Previous slide. Yes, this is always is a systematic process. One has to depend on several other technology. I think this is very popular picture. It is there in Google if you Google it. So one can easily correlate that sensors and actuators, which are essential component in Industry 4 technology, were available in 1933. Connectivity, Wi-Fi was there in 1971. Big data analytics even in 98. Cloud computing itself was there in 98, 99. But Internet of Things happened in 2010. Right? So that is how the technology happened. But today we are talking IoT, IoT, smart manufacturing, or smart factory. It is only because of the development, sustainable development happens in electronics. Next slide. Now at this stage, where we all look at is, yes, this is a time to discuss and develop this technology in an inclusive way. Of course, these are several, this is just to emphasize what it means, inclusive innovation process. There are different tools are there. So we need to follow this. I think this is where now we stand globally. Definitely there is a requirement of several technology, including a common language. Next. Next slide. So it is just like, you just click one more, next. This is basically for the people who are new, not knowing in what is Industry 4. Basically, Industry 4 essentially have 4 components. You try to understand what you are doing based on the realistic data which you capture from the resources, and then digitize and share to a stakeholders. Stakeholder here may be a production guy or your finance guy, or it is the maintenance guy. So share those data, required data to him. So wherein you do the analytics, that analytics leads to a predictions or forecast. Then these can be taken back to the resources. Then that leads to a automation or autonomous decision making. These are four essential aspects of Industry 4, no matter whether the Industry 4 is implemented in your production shop or Industry 4 is implemented in your cake manufacturing shop. This fundamentally drives the kind of enhancement of productivity, breakdown of maintenance, breakdown of machines, and effective utilization, that is OEE aspect of your industry, so that you could become competitive in the market. Next slide. This is another way. That means somebody may say that whether it is a new. No, it is not a new. This was already there. But what was the new? What is new is, say for example, let us take a machine shop. There is an operator operating a machine, some operation, but something went wrong. Typically in the shop floor, what people are doing, so this person will reach out to his supervisor or the production manager, who is so-called expert, and he himself will usually talk over phone, or he comes and inspect and then try to fix this problem. But this could be done in now with the technological evolutions, right? So there are technology which are capable of understanding what went wrong and then gets compensated itself without even to the notice of the operator, which is of little higher end. But the lower end is maybe it gives just an alert to the operator. Yes, look, this is what is happening. So either you need to stop or you need to fix this problem. That's the kind of is a low end automation or digitization. That is what otherwise, yes, this integration was earlier it was hard, now it is soft. So depending on at what stage is the fourth stage, what I mentioned, acquire, aggregate, analyze, and action. There are various technologies being developed and being developed. Next slide. Yes, now the question is, so I'm being an industry. So my job is finally engineering of product. I know engineering of product is not straight cut. It is a process, because one has to address all these 5 F's. Form, that is related to geometries like geometry, motion, interfaces, constraint. Function, because products are designed for a specific function, for specific applications or specific users, and then for even for specific locations. Then yes, engineering of products involves a lot of flows like mass, momentum, energy, informations, and also it is built upon the basic, that is physics behind it, that is with respect to application, with respect to process modeling and limiting functions, dominating functions, all. But at the end of the day, yes, this is a economics, fabrication, it is a process, machines, then its performance, lead time, and then cost. So this is a process. There is no other alternative, no matter whether you make a water bottle or you make a car. One has to go through this process. And we also know in engineering 1 plus 1 will never be a 2. It is always either 2 plus or 2 minus. So the question is how closely you are, that means how close you are to the targeted, that is 2. So now whatever technology I'm looking at, so if I look at Industry 4 is the technology which makes me productive in achieving as nearer to as 2, considering this all 5 F's attributes. So there are few questions one has to answer. This is still not very well evidenced in many of the sectors, and particularly in India, it is really still long way to go. The first one question is, how does Industry 4 helps in addressing these 5 F's? So it is really not dealt to a great extent for all the sectors. Yes, there are few sectors, particularly the process industry. There are many such are there, but there are few things it is not there. Say for example, I will take an example of a turning operation. We mechanical engineer, we can easily list 10 to 15 parameters which attributes to just a surface finish which is achievable in turning operation. But operator has only 4 parameters on his control. So now the question is, how do you make this process intelligent so that all these attributes, 10 to 15 attributes, effects on the specific parameters could be controlled. That is how to make this process intelligent. So this is one just example, but there are many examples in all the aspects. Then as of now, there is no versatile solutions. So this needs to be customized, and standardization is another. So I said nothing, but yes, there are in the process, but still a lot of localization and customization is obvious. So that makes difficult for the standardization. I think this OPC is one of the such first and fundamental requirement towards standardization. Next slide. And second is when we look at this industry 4 and all, but you cannot look this into an isolation, because the manufacturing involves these three essential components. That is manufacturing process, that means process has to be intelligent enough. The manufacturing equipment, that means your machine should be smart enough. And you should also address the other aspect, you should have a smart operation systems. So that means industry 4 is being implemented, covering all this, then only you can able to realize the smart factory. So with this background, CMTI has been our center at the Smart Manufacturing Center. We are trying to develop some of these solutions, both following cooperation and collaboration. We collaborated with about 6 industry, and we also working with, we have created a test beds that would facilitate, we will cooperate with the other co-developers for technology acquisition and also implementation. Next slide. So we have conducted several awareness program. So there were a lot of queries which were, I think some of them I mentioned in the previous slide. At this moment, our advocacy to small scale industry is, one is there is no universal technology, you need to customize. And also there are several attempts are in process to develop some of the standardized practices, so that one has to look at engineers as well as indigenous technologies. And Indian industries being a MSME focused manufacturing sector, I think no one will accept if I go and say that you change your capital and buy, integrate completely smart machine. It is not going to happen. So definitely there was, our center particularly, we are trying to focus and help MSME converting their individual legacy machine into a smart machine. That is one approach. And second is, once you can able to do that, then try to work on connectivity of the machines. So once it is machine to machine connectivity or interfaces established, then you look at the shop floor, connecting shop floor to the public network. Maybe big data and analytics and enterprises management, maybe for MSME it is little difficult to have. The reason is the HR is the major constraint. But the fortunate thing is there are many startups have been started, particularly focusing on this big data analytics, data sciences, manufacturing data science management. I think these services could be made available to MSME in a near future. So next slide. With this background, yes, there is in India there are a lot of emphasis has gone from the government side. That is one of the major initiative from Ministry of Heavy Industry, that is our parent ministry, has come up with the programs like Samarth Udyog Bharat. So wherein the 4 such centers have been established, one at CMTI, another at IISc Bangalore, another third one is IIT Delhi, and then one more is at private Kirloskar Center of Learning in Pune. These Samarth centers are similar and at the same time focusing on different aspects of I4 technology pillars. Next slide. Say, for example, I'm saying this Pune Center, they have conducted a survey I'm just showing 2-3 slides what they find with that survey. This is like 3 parameters they assessed: limited awareness, underdeveloped system ecosystem, and implementation support. Their survey indicates that there is varying definition of Industry 4. So it is not very well understood to many of the companies. Appreciation of relevance to the business is not kind of still industry are not able to reach, and then limited perceived value. Because my kind of comment to this condition is, as I said, there is no universal technology. Today, if somebody asks that, okay, can you implement this technology, any technology which gives you right, very well evidenced ROI? No. Answer is no, because it should be implemented or customized to local, your company and your machine and your shop floor. So that is how it happens. So I think that will take some more time. And implementation support, ability to design and implement pilot. This is where the MSME look at. And still difficulty in establishing ROI because of heterogeneous operational conditions and non-availability of universal technology. And then, of course, cost component is again, there is an issue for MSME and MSME. Then underdevelopment ecosystem, yes, because the many industries in India are in the transition of even 2 to 3. Many companies still, particularly the small scale industries, not even, just they migrated to Excel kind of data mapping. Beyond that, still it is not there. So that is where I think challenge lies. There is no role model companies in India. And in fact, that is one driver where our center at CMTI, we are establishing a smart production factory, so that one can come and look into that, how it looks like, then try to adopt or implement at his shop floor with local or customized solutions as it required for the company. And lack of embedded systems and IT adoption in SMEs, that's what I mentioned. So still there are poor connectivity, particularly in terms of even computerization is yet to happen. Then of course there are limited access to the solutions and support because still it is getting evolved. Next. Next slide. This is in another aspect. This is subject to depending on the area, like advanced manufacturing technology, additive manufacturing technology, then IIoT aspect, and with respect to CapEx spends and all. This study has done a little detailed study. What it says is over 50% of the organization either have no investment plans or plans to spend less than kind of 5% of CapEx in Industry 4 adoption. I think that is the kind of indication what Indian company today with respect to Industry 4. Of course, this study more of MSME focused. Next. Depending on this outcome, then there are many activities. Basically, we try to identify it in our summer center, which are funded by our ministry. So it's like technical consulting, then business consulting, pilot designing, adopting startups and startup mentors. That is where, and also conducting as like several awareness programs. I think our summer centers, all the 4 centers are focusing on this. In addition, we like CMTI Center is establishing a smart factory, which is a production factory, demonstration cell. And similarly, IISc Center works on different technological aspects, little more of software dependent kind of solutions. So and then IIT Delhi, they're coming work a little more focused on the control aspects. Like that, we basically there are different problems. We all four centers are collaborate each other and work together. Next. Next slide. Yeah, I think it's more details is not readable. Basically, there are different parameters have been identified. We, the Summer Center, we have conducted a survey amongst industries, both MSME and also large scale industry. What I find is, yes, that 50% what we have mentioned is more of small scale industry status. Next slide. Yeah, now I think we are working on different other aspects. The basic idea is that these challenges has to be addressed. One is where to start Industry 4 journey. This is where the industry looking for an answer. How to prepare a systematic digital transformation roadmap in the company. Are my suppliers, customers ready for horizontal integration of Industry 4 solutions? I think these are the fundamental questions has to be answered. And the solution would be, yes, understanding where they are in the journey towards digitization, identifying and setting a priority. So for immediate opportunity areas for digitization and creating a successful digital roadmap for the company. This is where the Summer Centers coming in hand supporting the MSMEs in a different way, starting from awareness program to demonstration of a smart factory. Next. This is another study. It is conducted for specific applications. Like that, there are several studies were conducted. This is for plastic component manufacturing, that is components produced by injection molding. So our centers try to help the MSME in identifying the complete value chain, manufacturing value chain of their business profile. Next slide. Next slide. Yeah, what we do with our center is particularly CMTI center. This is we build a machine. We are basically machine tool builders. So we are working on building smart machines and devices, then making manufacturing process intelligence, and then training, and then technology transfer and incubation. The next slide I will show you. So next slide, please. Basically, that is what the pictorial representation. These are our industry partners. We closely work with the leaders like Siemens, Hexagon, then including industrial association like Indian Machine Tool Manufacturing Association, HAL, and also companies like private companies like 𝐓𝐡𝐞 Technologies, which is a software company, and 𝐓𝐡𝐞 is a component subsystem manufacturing company. We expect that these technologies are developed together. What I mean, again, I recall that this collaboration and the cooperation. The next slide. This is what the smart factory, which is being established at CMTI. Here we try to next, just click. Here we try to click once again. We are trying to mimic complete factory, and it is like smart production factory. This is, as I said, there are two purposes. One is showcasing, and second is providing a services like a test bed. This is one of the machine I just give as an example, that is smart machine. The next slide. This is diamond turning machine, which is embedded with 8 sensor modules with all self kind of gets compensated for varying operational conditions in situ. This is true, in true sense, it is a smart machine. I think that is the capability what CMTI we have, so we can build various smart machines. Next slide. Here I will give one more example. Recently, jointly, this is one of the example where we collaborated with 3 research establishments like NIST, CMERA, and CMTI, and with 7 academic institutes. We try to develop IIoT implementation on the metal casting. I think this project is quite successful. So now go to next slide. Here what we are trying to do is, metal casting is, even the automated metal casting looks like this, the left side. So we wanted to convert this kind of foundry, metal casting foundry, to a foundry which is schematically shows in this. We wanted to establish a smart foundry where all machines are connected, and it can be established within the 25 square meter area, within 25 lakhs, and it is completely smart. That is a concept we started with early 2017. So now this has been developed. Next slide. This is the team. So definitely just click once again. Developing such solutions need a multidisciplinary team, and starting from mechanical, manufacturing, materials to software engineers. And the first picture, top picture, was when the project was initiated, which captured at Vihar Lake of IIT Bombay. And then this picture is at CMTI when our first baby burned out. That means first casting produced in November 2019 out of this smart factory, smart foundry systems which we developed. Next. I think this is a good, clear demonstration that a heterogeneous team can develop, and this complete starting from part design to then hardware, then sensors integration, including IIoT platform for metal casting. Nothing is there globally now, and data visualization, evaluation. Complete solution is developed by the group of 10 research groups. Next.
Dr. Nagahanumaiah, can we conclude? We are running short of time.
Yeah, there's the last. Next slide is the last one. I think you can go to next slide. So basically, this is what we have developed. The factory, that is basically the foundry within the footprint of 16 inch by 18 inch. Next. Yes, all our centers are primarily focused on imparting practical based learning to address 4P challenges, and we strongly believe on collaboration and cooperation. I think VDMA means a lot. Collaboration with VDMA means a lot in acquiring or integrating this Industry 4 technologies in Indian manufacturing. That's what I believe. Next. So the last slide. So can you move to last slide? Next slide. This is what CMTI does in one slide. We develop a range of machine tools, then aircraft LRU test rigs, and now CMTI has about 54 technologies which are ready for licensing. Of course, there is an open innovation platform is there. You just log in. So now MHA is created. Industries can pose the problem, seeking solutions. In our platform, we have about 3,700 users and experts, and then the students. Already 28 challenges have been hosted. I think I invite industries to host the problem, and also individuals to register as a problem solver and provide your solutions to the problems, industrial problems. So thank you very much.
Thank you, Dr. Nagahanumaiah. I think it was a very interesting and detailed presentation. You spoke about the 4 Ps, very important, 5 Fs also, and also you mentioned about the Samarth Udyog Bharat 4.0 platform. And I think was very interesting was also the assessment model Industry 4.0. I think we all need to compliment the good work CMTI is doing, Dr. Nagahanumaiah, and wish you and the team further success in your endeavors in this field of Industry 4.0. and VDMA and its members would be happy if we can add some value or add some benefit to your endeavors also. Thank you. Thank you.
Thank you, sir. Thank you very much.
Yeah. Friends, now we will have the poll question. Before I invite my colleague Heiko Herden, we will have the second poll question, which will be followed by a short video on 𝐵𝐶 UA. So can we have the second poll question, please? So friends, let's come now specifically to 𝐵𝐶 UA, and how many have already implemented the 𝐵𝐶 UA in your company? So we would like to know from our audience. So we'll give some time. So can we close the poll, Manon? So friends, yes, as the first question, I think keeping with the trend, so 61% have not yet implemented 𝐵𝐶 UA, and 18% in fact have already implemented, which is a good number. So I'm sure the following presentation from Mr. Heiko Herden would also be very useful and beneficial for the participants. So friends, before we go to the presentation from Heiko, we would run a short video on 𝐵𝐶 UA.
Together with mechanical engineering companies, the VDMA is developing 𝐓𝐵𝐶 UA companion specifications. Why? Open Platform Communication Unified Architecture, or 𝐓𝐵𝐶 UA for short, allows engineers a platform-independent, interoperable, and vendor-independent integration of different machines in production. The VDMA represents more than 3,200 member companies and is the voice of the mechanical engineering industry in Germany and Europe. The VDMA supports manufacturers in developing 𝐓𝐵𝐶 UA companion specifications. This ensures smooth Industry 4.0 communication. Industry 4.0 communication is ensured both between machines and from machines to other systems. This leads to more efficient production. For engineers, this results in the Industry 4.0 application fields of plug and work, condition monitoring, predictive maintenance, and OEE improvement. 𝐓𝐵𝐶 UA companion specifications define the form in which the machines provide certain information. This makes integrating the machines into an existing production environment and configuring machines much easier, of course, and it makes the engineer's work much more efficient. That's how Industry 4.0 works.
Friends, I think that was a good short example of 𝐓𝐵𝐶 UA and how 𝐓𝐵𝐶 UA can be implemented. And now I would like to invite my young and dynamic colleague, Mr. Heiko Herden, for his presentation on zooming in Industry 4.0, Introduction to the Global Production Language. Heiko, over to you, and we look forward to your interesting presentation.
Yes, thank you very much. I'm glad that I see so many participants here today. And as we have seen in the poll, it seems like some information on 𝐓𝐵𝐶 UA isn't wrong here. So let's directly start in the topic of the global production language. First of all, I want to say that I'm from the VDMA, and we have seen it in the video, and also Rajesh Nath already explained what the VDMA is, but one more word here. We are the Mechanical Engineering Industry Association of Germany. And what is very important for the later slides is that the VDMA is structured in 38 different trade associations, and all those are working more or less on those companion specifications we have seen in the video, but I will get to this later. So let's get started in the topic. We want to connect machines and we want to connect them on different levels. So there is the horizontal networking and the vertical networking. And so what is the horizontal networking? This means that the machine is on the same level with, for example, another machine. Then we have the machine-to-machine communication or communication on the field level. And vertical networking means that the machine is communicating with something on another level, so maybe into a lower level to a component, or in a higher level to an MES system, an ERP system, or a cloud system. And these are the two kinds of networking. And in such a network, we will find different components, so different machines, different components, different systems. And I have an example here, which you can see on the picture. We have, let's call it a system which takes out luggage from travelers and puts them on a conveyor belt. And if we go deeper into this picture, we will see a lot of different involved components from different sectors. Like I said, we have 38 sectors in the VDMA, and only in this picture we can see some of them. So we have a robot arm there with an industrial image processing applied to it. We have a gripper as end of arm tool on the robot. We have weighing technology on the conveyor belt. We have an electrical drive as well in the robot, as also in the conveyor belt itself. So these are some different involved components, and they all have to work together. And in the end, they also need to communicate with some sort of system. It might be in the cloud, but it might be some IT system within an airport, for example. And what we want to have is manufacturer neutral interoperability in the industrial environment. This is what is desired. And what does this mean? It means the components we have seen should easily work together, as easy as if you go into the market, you buy a new printer, you connect the printer to your home computer, you plug in the USB plug, and it will work, or maybe it will install some driver, but it will work afterwards, and you don't need some expert to come to your home and to adjust it for several hours. It will work. This is what's called plug and work, and this is what we are aiming for in the factories as well. And to achieve this goal, we figured that OPC-UA is a solution. So OPC-UA, as you have seen in the video, stands for Open Platform Communication Unified Architecture. It's also an IEC standard, and it meets all the different requirements for the mechanical engineering. And these are, for example, that OPC-UA is open source. It has security built in by design, which is very important in these days, that you have a secure transmission of your data, and also profile management and user management and certificate handling and stuff like this. There are various protocols that are part of OPC-UA. I will tell you a little bit more about this later. And this is a very important point. OPC-UA has the possibility to have semantic machine descriptions in those companion specifications. And also quite a good point about OPC-UA is that it is scalable. So you can have it in very small embedded devices in the field, as well as on a very good and strong computer running some Windows or Mac software. And all works together in the end, all those OPC-UA clients or server. So what is OPC-UA, the technology? It consists mainly of two parts. We have the part of transportation and we have the part of information. And I want to go through those two parts and tell you a little bit more about it. So let's get started with the transport. Like I said, the basis for OPC-UA is that there are several protocols involved. So several communication protocols. You might all know them by browsing in the internet. So we have protocols like UDP, but also TCP. We have MQTT. So AQTP. We have a lot of protocols that are part of OPC-UA, and this is very important because we want OPC-UA to be something like the universal interface, and so it's quite good that we have those different protocols. And there are different transport mechanisms. We have the client and server connection, and we have a publish-subscribe connection. And I will tell you a little bit more about what is client-server communication. So in this example, we have two devices, an OPC-UA client and an OPC-UA server. And in this example, the device 1 requests information from device 2. And device 2 answers this request later on to device 1. And what you can see here is that this is a one-to-one connection, and it is analog to read received in instant messages, for example. Then we have the client-server communication via subscription notify. In this example, we have 3 devices, and here a client accesses information from the server via a permanently configured connection. And in this example, device 1 now subscribes to the information from device 3. And as soon as the information in device 3 changes, the device 3 will inform device 1 and send the new information. And this is like we have in football live tickers, for example, that we get a notification on special events like goals or red cards or the end of a match via SMS. And then the third mechanism is the PubSub, or publisher-subscriber communication in OPC-UA. This means that the publisher sends the information out to unknown subscribers without a fixed connection. So this is 1 to N. And in this example picture here, we see 4 devices. And here the device 3 is the publisher, and the publisher sends out the information. It doesn't really know who receives the information, but only those devices who have subscribed to the information will get it. So in this example, device 1 and 2 have subscribed, they are subscribers. In this case, and device 4 might have also been a subscriber but didn't subscribe to device 3 in this example. And you can describe this as setting a radio frequency in your car. So the radio sender sends out all the information, and it doesn't really know who listens, but if you adjust your radio frequency on this on the right channel, then you will listen to it. So we have seen, okay, that's the transport of OPC-UA. And like I said, it's a little bit like a universal plug. So let's take a look at what I mean. In the world, we have different power plugs. So for example, we have different shapes, and we also have different content. In Germany, we have 230 volts, in the USA 120, in Malaysia 240, and we also have different frequencies of the current, so 50 Hertz in Germany, 60 in the USA. And if we apply OPC-UA now on this abstract example, then OPC-UA acts like the universal plug. So you can put all the different plugs in. And this is what I was talking about with the protocols. There are a lot of different protocols in the field. But if you use OPC-UA, you can have all those protocols within OPC-UA. But the problem is the content. When we apply OPC-UA on the content, we still don't get a really standardized solution because, as you can see here, we don't know how many volts and hertz. But if we describe it in OPC-UA companion specifications, then we get a standardized solution. For example, here 200 volts and 55 hertz. So we need to do something on the information level. And this is how I get back to this slide here. So we have the transport on the bottom, which is very important to have our solution in the end, but we also need the information part. And this consists of different levels. So on the first levels, we have the 𝐓𝐴 meta model. There we have the description of things like what is a string, an integer, so very, very generic information. Then we have built-in information models which describe, for example, some basic things about what is a device. And those things are handled by the OPC Foundation. On top of that, we have 𝐓𝐴 companion specifications. So every domain, for example, the robotics, describes the information which an interface of a robot should have. And for the field of mechanical engineering, the VDMA is leading all those companion specification groups. And on top of that, you can still have vendor-specific extensions, which means that if you have something that is quite special and is maybe even a reason why you sell your machine and not your competitor his machine, then you don't put it in the standard, then you have it on top. And now let's take a look at VDMA organizations. Mentioned the 38 trade organizations. You can see them here. And now let's see where we have 𝐓𝐴 companion specifications standardized already. So I marked them in blue. When they have something out on the market already, it's either a release candidate, which means you can still comment on a draft, or it is a fully released companion specification, which means it has been already a release candidate for at least 90 days. So we have the compressors, compressed air and vacuum technology. We have food processing and packaging machinery. We have glass machinery, machine tools and manufacturing systems, machine vision. There are quite some companion specifications for the field of plastics and rubber machinery. We have the field of pumps and systems. We have field of robotics, like I mentioned before. We have the field of weighing technology and woodworking machinery. So there are quite some companion specifications out already. You can download them on our VDMA homepage, on the homepage from the OPC Foundation, or on GitHub. The companion specifications are free, so you can just use them. If you want to get involved in creating companion specifications, you have to be either a member of the OPC Foundation or the VDMA. So let's take a look at what groups are working on companion specifications at the moment. And as you can see, it's even more. I marked them in orange here. So we have additive manufacturing, air pollution control, automatic guided vehicles, cranes, foundry machinery from the field of metallurgy. We have integrated assembly solutions, which is doing end-of-arm tools like the gripper we have seen before, intralogistic systems, laser, length measurement technology, mining, power transmission engineering is working on electrical drives. We have printing and paper technology, productronic, surface technology, which is handling the material supply systems at the moment. And in textile machinery, we also have a group working on a companion specification. So in general, you can see that we put a tremendous effort on 𝐓𝐴. We have more than 25 sectors in active development, more than 35 active working groups, and this means that more than 600 companies are involved in describing those companion specifications. So we want to achieve interoperability. That's what I said in the beginning. Now let's see where we are. So we started with Industry 3.0, which was proprietary communication. And now we are going towards Industry 4.0. And with OPC we have a meshed communication network, which is the basic or the base for everything. And with those groups I have just shown you working on companion specifications, we have domain-specific harmonized information models, which is the next step for Industry 4.0. But to really achieve the idea of plug and work, we need cross-domain harmonized information models. And to get those cross-domain harmonized information models, we have a group or a companion specification called OPC for machinery. And I will tell you a little bit more about OPC for machinery now. The OPC for machinery, like I said, is a 𝐓𝐴 companion specification, but it's not just for one sector like the robotic or the drives or the woodworking machines or the glass cutting machines. This one is really for the whole mechanical engineering industry. And in machinery, we define harmonized basic building blocks for the broad use. And each building block stands for a specific use case. This means that those building blocks can be referenced from other companion specifications or implemented as a standalone model. So for example, as you can see in the picture here, we have a use case machine identification. And if you as a textile testing machine companion spec say, yeah, we want to have the use case of machine identification, then you can just take the building block from machinery and you will have the same interface as everybody else who would take the building block from machinery. And so to speak, we can say 𝐓𝐴 for machinery forms the basis for interoperability. Like I said, it consists of several building blocks. So we have two released building blocks, which is the identification of machines and components, and also the building block to find items in a server. So for example, find all the machines in an aggregating server or find all components in a machine. We will have two releases soon, one for the topic of machinery state and one for the topic of result transfer. And at the moment, we are working on two more topics, the topic of job management and topic of energy monitoring. And as you can see in the picture at the bottom, you will see that the 𝐓𝐴 for machinery is the VDMA base compact spec for the whole field of machinery. And on top of that, you will find the different other companion specifications. So for example, weighing, machine vision, mining, robotics, or it might be even a bit more clustered. So for example, we have the base specification of machinery. On top of that, we have a machine tool specification. And if it's a laser or a CNC laser machine, then we will have a laser spec on top. So, so it's handled. Let's take a look at those use cases I have just explained. First, let's take a look on the machine identification. This is for the question, what machine is it, who built it? If you are standing in a factory, there are a lot of different machines, and maybe you have an MES system who connects to all of them. And with machinery, it gets pretty simple. You get all the information available in the same way, and can also take a short look on the information that is provided there. So we have three mandatory parameters which you really have to have in your interface, then the product instance URI, the manufacturer, and the serial number. And those three guarantee that your machine is uniquely identifiable. And we have several more optional parameters. Some are provided by the vendor of the machine and some are provided by the user of the machine. The ones provided by the user you can see on the right side. So this is basically what our machine identification looks like. I don't want to go too much into detail because this is now 𝐓𝐴 information modeling specific, but just to give you an idea. And we also have the component identification, which is slightly different than the machine identification. So for example, we don't have a location which is needed there because usually a component is part of a machine and you know the location of the machine and you don't need a location. On the other hand, we needed an additional parameter, and we also have only two mandatory parameters here because you can't guarantee a unique identification of machines, of components, as well as as good as you can do it with machines. Then, like I said, we have the listing of machinery items. This is that we can find all the different machines in a server, in an aggregating server. So we have basically a folder which lists all the machines, and every machine has a folder which lists all the components of a specific machine. And we also guarantee that you can model special cases like that a machine acts as a component of another machine. But like I said before, I don't want to go into detail too much as we are a bit ahead of time already. But one more topic I want to address is the use case which will be out very soon, the use case of the machine state. And at the moment we have the problem, if we look at our production at all the different machines, we will find different states. Some states will only be numbers, but some will have words like working, running, executing, production, dry run. That's how it is at the moment. So every sector, every branch has different names for those states. But with the machinery specification, we get the same signal from all of them. So in this example, we will see, okay, all those machines are executing. I know everything is fine. And this is the machine view for the machinery state. The machinery state also helps when you look at components, when you have the component view, because in this example, we can see a beverage filling line that is out of service. So the red light means that it's out of service. And I ask myself, why is my machine out of service? And then I can look into the components and I can see, okay, the conveyor is yellow, which means it doesn't do something, but it could. And the injection is also yellow, which means it could do something, but it doesn't. The only thing that really is red is the gripper. And so I know, okay, I have a jammed gripper. This is the root cause of my problem. So this is quite a use case together with getting key performance indicators. So in this example, I know that my machine is 2 hours out of service, 1 hour not executing, and 5 hours in executing state. And with this information, I can get the machine availability. So I know that the actual production time is 5 hours. I know that the planned busy time is 8 hours. And if I want to know the availability, I can divide one through the other, and I will get an availability of 62.5% after the ISO 22400. And that's just one example how to use those figures you get from 𝐕𝐶UA for machinery. So let's get to the conclusion for this presentation. So 𝐕𝐶UA enables interfaces to be standardized in the course of Industry 4.0. It meets the requirements of mechanical engineering, like I have shown, with the scalability and the security built in by design and the possibility to have semantic machine descriptions. And it offers transport mechanisms and data modeling. The VDMA works on information models with over 600 companies involved worldwide in about 35 working groups. And we also developed a harmonization in the 𝐕𝐶UA for machinery. And this is really my message for you today. So if you use 𝐕𝐶UA, at first you might only try out how does 𝐕𝐶UA work, but later you will get to the point of the information and you will do an information modeling of your machine. And you should really use existing information models as basis for your own information modeling. And you should definitely use 𝐕𝐶UA for machinery, because in the future, 𝐕𝐶UA for machinery will be very important, as this is a really big step towards plug and work or plug and play. And this is really what I want to tell you. If you work with 𝐕𝐶UA, you should also consider using the 𝐕𝐶UA for machinery specification. So thank you very much for your attention. I hope it was interesting for you, and I'm looking forward to answer some of your questions. Thank you very much.
Yeah, thank you. Thank you so much, Heiko, for the very interesting presentation and really enlightening the audience on 𝐕𝐶UA. Friends, we will quickly have the last poll now before we take the questions. So can we have the last poll, please? Yeah, so friends, we spoke about 𝐕𝐶UA. So how important do you think the implementation of 𝐕𝐶UA in global production language will be for your company in the future? Would it be very important? Would it be important, not so neutral, and not so important? So we'll give a few seconds for the response from the participants. So can we close the poll question, please? So that's very interesting. In fact, 61% of the respondents have mentioned that OPC UA and GPL would be very important. I think that really adds a lot of benefit then to this web seminar we had today. And 24% mentioned it's important. So almost, if you look at important and very important, it's almost 85%. Thank you very much. Dr. Nagahanumaiah, are you there with us? I would request you then to switch on your camera if you're there. Yes, yes, thank you. We'll quickly take a few questions. Dr. Nagahanumaiah, maybe I'll ask the first question that has come for you. This is, do you have any examples, Dr. Nagahanumaiah, of the Indian companies which have adopted Industry 4.0? From CMTI point of view, or some of would you be able? Yes.
There are many companies have adopted different components, but this completeness is always a subjective. So, say for example, if you come to visit to CMTI, I adopted some of the solutions for the metrology, and I have developed some of the technology and OE aspect of machine tools and all. If you look at completeness, that is completeness is always subjective. The reason is, as I said, there is no universal technology for the Industry 4. This needs to be customized. Okay, there are technology with respect to, say, for example, connectivity aspect, or with respect to cyber physical system, subsystem edge controller, and there are established protocols to streaming of data to server and all. Those definitely they have been implemented to a great extent, but yes, complete factory is still not Industry 4 enabled.
Okay, right. Heiko, coming to you now, do we have certain use cases? Because when we talk about certain aspects like predictive maintenance, condition monitoring, so Heiko, could you highlight some of the use cases? How this can help for predictive maintenance and condition monitoring?
Yes, for all those use cases, you need data. So for condition monitoring, for predictive maintenance, you all need the data of the machine. And OPC UA is quite important there, because with OPC UA you get data, and with the companion specification you get those data in a standardized way. So you know, okay, this data point means something, and you know what it is, and you don't look on it and say, oh, okay, it's a lot of data, I don't know what to do with it. But with the companion specs, you know exactly how to use the data, and then you can do the use cases, predictive maintenance, condition monitoring. You can also use an AI at the end and stuff like this. So OPC UA and the companion specs is an enabler for those different use cases you mentioned.
Right, right, right. Dr. Nagahanumaiah, actually, there are a few questions people have asked. They want to implement Industry 4.0. So I think in these cases, we would forward your contacts to them, so that is that okay? So that they can get in touch with you. Right.
I will be happy to discuss with them. And
sure.
Both the customized solutions can be developed, and also there are solutions which are available off the shelf can also be integrated and demonstrated to the industry.
Right, right. So friends, we are running short of time now, so I would now like to invite Mr. Julian Wilms from GIZ. Julian, I hope you are with us. Yes, good afternoon, William. Good to see you. Julian, it's really nice, and sorry you had to wait a little longer because I think we had some very interesting presentation. So friends, Mr. Julian Wilms, he's the head India country component of Global Project Quality Infrastructure at GIZ. And I would now hand it over to Julian for some remarks and address from his side.
Thank you, Rajesh. And thank you to all speakers and participants for a very interesting discussion on global production language. We have learned today about the relevance of the OPC UA standard for the adoption of Industry 4.0. I think this relevance is underlined by the commitment of the German Economics Ministry and its participation in this event today. And it is also underlined by the amazing list of participants from renowned companies from Germany and India, showing a great interest in the topic as such, as well as in the practical implementation of the global production language. The topic of global production language is also an important objective of the Indo-German cooperation on quality infrastructure. Together with our Indian partners, we jointly work together harmonizing the framework conditions for Industry 4.0 between our two countries, but of course also internationally. Quality infrastructures describe the systems put in place to ensure products and services and that they are safe and of high quality. It covers everything from standardization and conformity assessment to accreditation, metrology, and market surveillance. Thus, quality infrastructure plays a vital role in business, innovation, and trade, both nationally and across borders. The cooperation with India takes place within the working group on quality infrastructure, and this working group brings together a broad range of stakeholders from India and Germany, which are ministries and experts from the public and private sector, including technical organizations, industry associations like the VDMA, and of course also corporates like those who are with us today as our esteemed participants. Industry 4.0 is one of the multiple sectoral topics the German Ministry for Economic Affairs and the Indian Ministry of Consumer Affairs, Food and Public Distribution agreed to cooperate upon as part of the activities of this working group. And of course, also global production language as an important driver for Industry 4.0 is a relevant aspect of this exchange. Because for the implementation of Industry 4.0, this role of standards is essential. And Industry 4.0 involves the integration of various systems across different domains, hierarchy levels, and different phases in the life cycle of a product. So this makes a structured and coherent approach to Industry 4.0 standardization and international cooperation in this area so crucial. We therefore look forward to continue also the dialogue with you and are open for your ideas and suggestions. And before I close, I would like to once again thank our partner VDMA for his support in jointly organizing this exchange. So thank you, Rajesh, and thank you to your wonderful team. And last but not least, I would also like to thank my colleagues from the Global Project Quality Infrastructure for jointly setting this event up with VDMA. And of course, I would also like to thank again Mr. Stöckl-Pukall from our German Economics Ministry, as well as the other speakers for their time and contribution. And with that, I would like to hand back over to Rajesh again. Thank you very much.
Thank you so much, Julian, for this address. And Julian, you mentioned about the good large number of participants, and I would also like to share with Dr. Nagahanumaiah as well as with all our participants. We had participants from the automotive industry, auto component, construction equipment, heavy engineering, plastic, machine tool, energy, automation, welding and cutting technology. So it was very encouraging to see that we had a broad range of participants from various sectors and various companies. I think this is very encouraging. And also on behalf of VDMA, we would like to thank GIZ, Julian, and you and your team. Janina also was very helpful. Also my colleagues from VDMA, Manohar, Pavana, for putting this so well together. And Dr. Nagahanumaiah, thank you so much for your interesting and detailed presentation. And also Heiko, I think it was really a very good presentation and gave a lot of information to our participants on OPC UA. And of course, Mr. Stöckl-Pukall from the Federal Ministry of Economic Affairs. And last but not the least, I would like to thank all our participants who really stayed with us for a long period, although it got slightly extended, but we still have a good number of participants who are online with us. So thank you very much for sparing your time and being with us. And we sincerely hope we could provide you some valuable information also on Industry 4.0 and OPC UA. So friends, stay well, stay safe everyone, and all the very best for the future. Thank you and goodbye.
Thank you.
Thank you very much again. Bye-bye.
Thank you.
Bye.
Thank you. Bye.